All right, in this video, we're going to talk about symmetry and how to determine if a equation, if its graph has y-axis symmetry or symmetry about the origin. X-axis symmetry works just like y-axis symmetry, just you'll see, but it's not as important because if something has x-axis symmetry, it's not a function. So first, let's look at the graph. Now, there's a way to do this without a graph, but the graph will help us understand what's going on. So I'm going to graph x times y to the negative third power equals 5. And I see that that has symmetry about the origin. It looks like it. If I twist this graph around about the origin 180 degrees, it will rotate onto itself. Now, let's say I had a point 2 comma negative 1. All right, if I wanted to rotate that 180 degrees about the origin, I would change the x value and change the y value. Right? And that works for any point. If I made this 5 comma negative 1 and then change the x and y coordinates, the sign of the x and y coordinates, notice how that's 180 degrees about the origin. All right, so by changing x for negative x and y for negative y, that's how we rotate something 180 degrees. So if we do that here, if we replace x with negative x and y with negative y, we see that the graph will rotate onto itself. Right? Now, that works for any type of graph. Like if I did y equals x minus 1 squared, and I wanted to rotate that 180 degrees, I would do negative y equals negative x minus 1 squared. And notice how that red graph got rotated 180 degrees about the origin, but it didn't rotate onto itself, which means that it doesn't have symmetry about the origin. All right, so that's how we could check it with a graph, by simply looking at the graph and seeing, all right, does it rotate onto itself when I rotate it 180 degrees about the origin? The way we do it algebraically is to replace x with negative x and y with negative y and show that it's the same graph. So I could do that graphically or algebraically. So algebraically, we have to show that these two equations are the same thing. So what do? You take the top equation, you replace x with negative x, y with negative y, and then you simplify it to either show it's equal to that, or if it's not, then that means it doesn't have symmetry about the origin. So negative x can be written as negative 1 times x, all right? And then negative y to the third we could bring down here, all right, with a positive 3. And then that is the same thing as negative 1 to the third times y to the third equals 5. Now, negative 1 to the third is equal to negative 1. And negative 1 over negative 1, that just cancels out. So we get x over y to the third is equal to 5 when we cancel out the negatives. And then we could just rewrite this by bringing it up with a negative exponent. And we see that it simplifies to the original equation. So this in red would be an algebraic proof of why this has symmetry about the origin. And to show that it doesn't have y-axis symmetry, well, if something has y-axis symmetry, that means for every x value, there's an opposite x, but the y value stays the same. So if I just change this to that, all right, the black graph would be the blue graph reflected over the y-axis. Now, if I try to simplify that, it wouldn't simplify to the original equation. It would be negative x y to the negative third equals 5. The original equation was positive x to the negative third equals 5. So it's not the same thing. So that's why it doesn't have y-axis symmetry. All right, and if you wanted to reflect something over the x-axis, all right, a point reflected over the x-axis, like let's say I took this point 2 comma 1 and reflected it over the x-axis, that would be 2 comma negative 1. All right, so I change the y coordinates sign, but I don't touch the x coordinate sign. So if I made x the same thing, but made that negative, all right, that's what a x-axis reflection would look like. In this case, it looks the same thing as a y-axis reflection because, it has symmetry about the origin. So that's going to happen. So this doesn't have x-axis symmetry either because if I simplified this, it wouldn't simplify to that. All right. So in the writing I did earlier in the video, that would be showing that 1A has symmetry about the origin. Now for B, all right, so first thing I'm going to do is I'm going to type that in and see what the graph looks like. But you might have to do this without a calculator. So I'm just showing you what the graph looks like at the beginning of the problem. So when I'm explaining it, you have some sort of picture to connect it to. All right, so that's going to be y equals x to the third, and then 6x minus x cubed, and then minus 5. Okay, so if I look at this graph, this looks like it has symmetry about the y-axis, all right? And that's because it does. Now, for something to have y-axis symmetry, for every point xy, there should be a point negative x comma y. So if there's a point 2 comma 27, there should be a point negative 2 comma 27. If there's a point 1 comma 0, there's a point negative 1 comma 0. If there's a point negative 2.478, sorry, positive 2.78 comma negative 10.297, there should be another point with the opposite x value, same y value. All right, that's what y-axis symmetry means. For every single point, it has that. So if I replace negative y with y, negative x with x, all right, that's going to reflect this graph over the y-axis. And if it reflects onto itself, that means it has y-axis symmetry. All right, and I think I typed something in wrong because I'm missing a parentheses here. All right, this should have y-axis. Oh, okay, so you know what I just did? I replaced x with negative x and y with negative y. So notice how this got rotated 180 degrees, because that's the rule for rotating 180. If I just replace x with negative x and don't touch the y, then it rotates onto itself. Right, so this does have y-axis symmetry. Now, the way I would prove that without just looking at a graph is to show that this simplifies. All right, this is like for every point x, y is going to equal that. All right, for every point negative x, I have to show that y is the same. So I have to show that this simplifies to that. So y equals, all right, negative x cubed could be negative x cubed like that. You could pull out the 1 because any negative raised to a third power would still be negative. And then negative 6x plus x cubed, and then minus 5. Now, if I take this negative here and I distribute it, then I get y is equal to x cubed times 6x minus x cubed minus 5, which is the original equation, which means that this does have y-axis symmetry. So there you go. You just showed it has y-axis symmetry, and you don't even need the graph. You just showed that for every point xy, there's a point negative x comma y. All right, if you wanted to show it had x-axis symmetry, you do the same thing, but you would replace y with negative y and not touch x. If you wanted to show it had symmetry about the origin, you replace x with negative x and y with negative y, and you'd be done. All right.